Hello. In this video, I am going to show you how I go about taking the business concept and revenue assumptions that I have for my library cafe and developing that into a revenue estimate. Keep in mind your assumptions and your business might vary, so you'll need to structure something different, and you can certainly talk to me about that. First thing I've done, since I knew that I was going to have student, faculty, and staff kind of breakdowns, I've already kind of created the labels for those. Then down here I have a total number of customer per day where I just add up my individual numbers of customers from each category. I have the average price in real terms. Then I have my inflation factor so that I can get to a nominal price. And I have the number of days open per period. And then lastly, I'll just combine it all, right? Number of customers times price per customer times days per period to get the periodic revenues. I used month 0 as a holding place for any kind of expenditures or revenues or whatever, in this case just revenue, that might happen before the business actually goes live. In this case, we won't have any, but you'll see how that applies as we start getting down to expenses. So we're going to start out with the basic assumption, students on campus in a typical day. We said there would be 12,000. Okay, you're going to see I use this convention over and over. Whenever I'm putting in a hard-coded number, I'm going to highlight that in yellow, and you'll see why later. We're going to build what's called a dynamic forecast. Dynamic forecast is primarily formula driven, and so whenever we hard code a number in, that's an assumption. Everything else is a formula, and we want to keep track of where our assumptions are so that if we wanted to change them, we'd know which cell immediately to go change, and that would take care of it. And so in this case, we're just going to assume 1,200, and then we're going to use the formulas to extend that out. Okay. So we'll extend that all the way out to year 10, because this is just how many per day. So right now we're making no assumption that the number of students on campus is going to change or grow over the next 10 years. Students on campus adjustment factor. Again, this for us was the thing that was going to say, well, that's how many would be on in a typical full semester on any given day, but we need to adjust that for whether this is a period that's full semester or not. You'll see I have a calendar over here. It's the same one I had in the presentation earlier where I built out these adjustment factors. So I'm going to copy those, highlight, and I'm going to go edit, copy, okay, and then I'm going to go over and do a little something different here. I'm going to do a paste special, and what I'm going to do is transpose. And the idea behind the transpose, I probably shouldn't have put those cells in there. I'll clear up that. I'm sort of you'll find it that I'm a little bit of a stickler for keeping my formatting clean and consistent. So no borders there, sorry. But the idea behind transpose is that if you have numbers that were in columns, it'll put them all in a row. If it wasn't a column, put it in a row, and vice versa. So kind of a nice thing. And that takes care of the first 12 months. Oops, sorry. Did that wrong. Gotta drag it over one because that started at month 0. And so the question is, well, what do I do for year 2? Well, in my case, kind of the logic is there's 12 months in the year, and if I took the average, think of this as a load factor per month in terms of what proportion of the 1,200 students will be on campus in any one month. Since I've got 12 of those and I've got the same weighting on all of those, I could just do an average. So that's what I do. I'll do equals the average of the 12 months worth of weightings. So starting with month 0, not with month 1. Okay. And so what that works out to is 65%. What that means is 65% of the time, on average over a year, we have the full accoutrement of students there. Or differently, you could say on average about 65% of students are on campus in any given day. I'm going to highlight that a little bit differently. I'm going to highlight that with a little gray color here. And the reason I'm doing that is it's not the case that this is an assumption, but it's a different formula than what I had used anywhere else. All of these were assumptions. They're just hard-coded, so I'm going to highlight them. That way we understand that we could go in and adjust the pattern if we wanted to. Okay. But the bottom line is now I've got this 65% on any given day, on average, 65% of students present. And I can just use a formula-driven approach to extend that out. So we just assume that throughout. And so the average number of students on campus per day equals, quite simply, equals this times this, right? So the students times the adjustment factor. So since that's all formula driven, we can just put it in there without anything. Now, you'll notice it had, as I went further out, it has these partial things. I don't like that, so I always go in and then round them. So round to the nearest decimal, or to the nearest integer, so 0 decimal. This is a little technique I'm using, control right. So in Excel, you can either control, I'm in the Mac version, so in Mac it's Command Shift, in Excel, in Windows it's Control Shift. But if you're on a cell and you want to highlight all the cells to the right of it, you hit the right arrow, and it'll highlight all the cells that have values in them, and that way you can get them all in there. And then what I did is what's called a right fill. So I could just highlight on it and have said, I guess this one doesn't have fill actually. No, but you can hit Control R and that'll fill right. Or Control D to fill down, I believe. Yeah. Anyway, you want to fill those things. So again, I could just do the whole thing, and I think there's a edit menu as well that may take care of that. Edit, fill, so you can go fill right. And if you'd highlighted a column, you could fill down. So now I have the sort of weighting here, and now what I need to do is get the number of customers per day. And going back to our assumptions, we said that we were going to average, we were going to start out at 10% in month 1, and that by the end of month 9, which is the end of the spring semester, we would be at 40%. Again, these are hard-coded, so I'm going to highlight them in yellow. And what we need to do is we need to fill in that kind of smooth, steady growth. So there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 steps going from 1 to 2, 2 to 3 that we need to increment up. And so the kind of the simple math to that would say, let's just take the difference between the number we want to end up at minus the one we want to start at, right? And we're going to divide that by 8 so that we get how big each one, the 8 steps, how big each one will be. And then we're going to add that to whatever the last value was, okay? Need to do a little parentheses work here to make sure that everything works properly. And since I'm going to drag this to the right, I don't want the columns to be adjusting when I do that. So I got to put $signs in front of these letters so that the columns stay put. And when I can do that, when I do that, you'll see it's about 3.75% increment each month in growth. And it's sort of a smooth growth up to 40. And after that, we're just going to assume that we are at a, of whatever students are on campus, we're going to have 40% of them over the remainder of it. So to get to the number of students on campus, we're simply going to take the number of students that we have, our weighted number, times whatever our percent of students that are customers. And so what that says is in our first month open, we'll get an average of 120 customers a day. Not too bad if you think about it. Probably underestimates some, but it's what we can do. And we're just going to extend that out. Now, when you get out to, never mind, we'll just go out to here. There you go. Now, what I like to do, and I've already got it in there, but what I like to do is whenever I get again, a value that has a customer count in it, I like to round it. So we'll do the rounding again. And we're going to do the fill right again so that we get it all nice and smooth. And when I get a number that is a sort of a critical result, if you will, that I want to be able to look at and draw attention to, I like to give it a different highlighting. So this way, when I go, point to things for somebody, I'll be like, oh, I see what that's based on. Very good. Now, because we have postulated basically the same structure for faculty as we did for students, we can just take all of this stuff, bring it down, and paste it right as is again. Now, we only have 100 faculty, so we can't do that. All right, I've got to make that change. Our adjustment factors for how many are on campus, remember we're using the same ones here. So in this case, instead of them being hard-coded, we're just going to go up and reference them to what's above for the students. Advantage of that is that when we make the change one place, it will take place everywhere, which we like, right? It also means that we can get rid of that highlighting. And so by doing this, what we've done is reduce the number of places that there's hard-coded stuff. You really want to keep that as absolutely minimum as you have to, the hard-coded stuff. I'm going to keep these percent of faculty kind of starting points and ending points. Remember, we're not going to end at 40, we're going to end at 30. So I got to adjust for that. And you can see it's basically already adjusted out for this. So it's suggesting that we might grow up to, maybe as much as 30 faculty per day, and on average 20 faculty per day in there. I don't think an unrealistic assumption. And again, I'm going to take this same thing. I'm going to go ahead and use the student one again for the staff. And the reason for that is that we do have to hard code in the assumptions about this adjustment factor for staff. So I'm going to go grab that from over here. Control C. And this time, to avoid having the lines come in, I'm going to do a transpose, but I'm only going to have it paste values, no formats. And that way it brings over the percentages that I want. It doesn't bring over, it leaves it highlighted all the things that I want. So it does all the good things that I want with it. I have to change myself to 300 faculty there. I've got my adjustment factors. And with the faculty, I believe we said, do you remember? Let me see if I have my PowerPoint up for that. For the staff, we said that we would go 20 to 40%. So we're going to start out 20%, grow to 40%. There you go. And so now all we need to do is to get our total customers per day, and that's just equal to the total students plus the total faculty plus the total staff. And you can just extend that on out. Remember, we could have a category in there for kind of other, being drop-ins from the neighborhood and so forth. I don't have that built in right now. But you could certainly add it. I think it would probably just be a plug number, as opposed to something where you would have to go kind of extrapolate from population in this case, though you may be able to do more. We are again assuming a 12.5 or $12.50 food cost, or sorry, average price per ticket. And we'll just make that, this is our real cost, so it doesn't have to be adjusted for inflation. So that's just formula driven all the way out for the whole time. Almost forgot. I'm just going to use a little different highlighting for these things that really represent a big number that we will care about, like total customers. So I'm going to use a blue instead of a gray for those, kind of draw your attention to it. So total customers. So we've got our real price. We need the inflation rate. Going to do 0% for the first period, reflecting the fact that it hadn't grown much. And hard code that. So got to be yellow. So leave it at 0% for the first 12 months. Okay, and that's going to reflect the fact that there was no real growth from month to month over the first 12 months. And at the end of the 12 months, we're going to start adjusting ourselves each year at 2% a year. So that's a hard-coded number. Okay, and you'll see how I make use of that here in just a second. All right. So then what I want to do is I want to calculate an inflation factor. This would be a number that I can just take the price and multiply by and say that will be the price based on that it was $12.50 at the beginning and it had been inflated. So we do that by simply saying it is equal to 100%. So 100%. Times 1 plus whatever the current inflation factor is. Actually, we're going to say it's 1 plus whatever the inflation factor is, right? Times whatever the prior value was. Okay, I didn't like that because my parentheses in the right place. So not a perfect solution here because we haven't put something over here, so we're going to put the 100%. That basically says my factor is the price today is the same as the price yesterday. And we're going to, since that's formula driven, we can drag that out. I'm going to show you what happens. So it goes to 102% there. So in year 2, prices will be 2% high, 102% of what they were, 104%, 106. So you can see it seems like it's kind of adding 2%. It's really not. It's multiplying. It's just you can't really see the cross product. So if we were to expand that a little bit, you could see that it's slightly different than what you think is going on there. So it's really 102, 104, 106.1, 108.2. So they're starting to be, it's 2% more than the last price. Not a big deal, but there you go. And then what you want to do is to know what the nominal price is, and that is equal to whatever the real price is times whatever the inflation factor is. So it's going to stay at $12.50 all the way through the first year. All right, kind of broken down here. And by year 2, it's going to go to $12.75. Year 3, it will go to $13.27, $13.53. So that's just the impact of inflation on this. And whenever you do modeling, you always want to make sure you account for that. Okay. Now you need to think in terms of the days open. Now you could go into each month and kind of count them up specifically. Probably our estimates aren't at that level of precision. We are planning on being open 7 days a week, basically, but for holidays. So we're just going to put in 30 days a month. Get you to 360, leaves a little bit of room for some holidays there throughout the year, right? And we're going to carry that forward all the way out to month 12, okay? Now, in month in year 2, we can't say we're going to be open 30 days because it's the whole period. So we're just going to say it's equal to 12 months times the amount per month, so 360 days. And I will just highlight that. It's a formula again. It's not a fixed amount, but the fact that it is a change in the formula means that I may want to go back and revisit that. So just makes it easy for me to remember. Basically, we're carrying the 360 days all the way out. And at the end of it, what's left is we just now need to figure out what's our revenue. Well, our revenue is just the number of customers times the price times the number of days. Okay, and I suppose I could highlight those in blue as well. I'm going to highlight the nominal price. I'm not going to do the other one because, first of all, it's pretty simple, but also because I don't want to blow away the highlighting of the yellow here. All right. So again, it's just equal to total number of customers times nominal price times number of days per period. So that comes up with what our revenue estimate will be. And that's formula driven. We can just carry it all the way out. Now, not a shabby estimate, $70,000 a month starting in month 1, growing. By the time you get to year 2 and you're thinking about total amounts in a year, you're looking at $2 million a year in revenue, just with inflation growth. So no assumption about picking up customers from outside or that the number of students at the school grow or anything like that. You grow to 2.36 million, so not too bad. And that is, you now have your revenue estimate. So that pretty much concludes this example. I'm going to save this file as my completed file. There we go. And there we go. Hopefully that's useful. Again, if you have questions, feel free to come to class with those questions.